So today, as we have covered the concepts of vertical circular motion, now we can see the some examples based on those concepts that we have learned in these last two lectures. Okay, so let's start with a good problem. Okay, the problem is like this way, guys. Let me just make the problem first. So question number one. Okay, so the question says like this, guys, that there is a track like this. Okay, there is a track like this, and this height is given to you. The height is h, and this circular track, guys, you can say is a of radius r. Okay, now there is a block here. Okay, this track is smooth, this track is smooth. So what the question is saying is, it is saying that a block is released from the top of a smooth vertical track which ends in a circle of radius r as shown. The question number one is, guys, find the minimum value of h so that block could complete full circle. Okay, guys, so this is the first problem. Second problem that it is asking is what, guys? If h is equal to 3r, then find the normal reaction when the block is at a point at a point A and B. Okay, guys, this we are calling as A, and this we are calling as what, guys? B. Let's say this we are calling as C. Okay, and the third problem, guys, is given is that if h is equal to 2r, then find the velocity at the find the velocity of the block when it loses the contact when it loses the contact with the track. So guys, these are the three problems associated to this question. It's a good problem to understand the concepts. So let's see, guys. Okay, so let me start with the solution, guys. Okay, so see, guys, what I have told you, that if this kind of a scenario where a vertical circular track is there, and the vertical circular track is there, and this block is there, in these kind of problems, guys, what we can do, we can use the idea of what, simply this string plus block problem. Okay, string plus block problem, that kind of a concept you can use to understand what are the requirements to complete the full circle or something. Okay, so guys, here we know that in this case the velocity needed at point A to complete full circle is root 5gr. Okay, guys, that we have discussed already. So if when the block is, guys, what, when it is coming here, okay, when it is coming here, it should achieve what, it should achieve the velocity of what, root 5gr. If it happens, then it means our job is done. So guys, to do that, if you see what we can apply, we can use the work energy theorem. Okay, so guys, here the work external, okay, that is happening, okay, that is equal to what, change in kinetic energy. If you see, so when the block is coming down guys, there is normal force which is acting, and the second is what guys, mg is acting. Normal force work done will be what guys, that would be 0, because normal force is what, perpendicular to what, the displacement of the body. So there is no work done happened from the normal force, only mg will do the work guys. And mg will do how much work, because the body will come at the point A after traveling what, h height down. So we can say that it has traveled h height down, so the work done will be what guys, mgh, and that is equal to what, change in kinetic energy. So half m v square minus 0 guys, initial kinetic energy is what, 0. So half m, v needed is what guys, root 5 gr, so it will be what, 5 gr. So guys, mgh is equal to 2.5 g into r. So guys, sorry, m is there, so mg is cancelled out, and from here we can say h is equal to 2.5 r. Okay, so guys, question number 1 answer is what guys, that height is needed how much, 2.5 r. Okay, now coming to the part 2 of the question guys. So part 2, so question number b. So guys, question number b is saying if h is equal to what, 3r, if h is equal to 3r, then what would be the normal force at the point A and at the point B guys. So they are asking in this case what is Na and what is NB. Okay, these are the two question that they have asked. Okay, so guys, by seeing the above result, what we have understood that if h is equal to 3r, particle will do the full circle for sure, because it will have more speed compared to root 5 gr. Okay, that's for sure at the point A. So it means it is going to have guys what, full circle. So at B point it will have some velocity, and at A point it will have some velocity. So if we just fulfill the centripetal condition there, or we use the centripetal condition there, we can get the result what we are looking at. Okay, so guys, if you see here, this is the point A. So here it will have some velocity, and it will reach guys here, it will have some velocity. Let's say this is velocity B and this is velocity A. Okay, so velocity A guys, if we want to find out, first we have to use the work-radius theorem again. Okay, so work-radius theorem, if we apply guys, the work done is what, mg into 3r. Okay, because mgh is what, h is what guys, 3r. So mg into 3r is equal to half m v square. Final kinetic energy is what, half m v square, half m va square guys, minus 0. Okay, so from here guys, if you see, m cancel, va is equal to what guys, it is root 6 gr. Okay, so now guys, here if you see, if I just try to fulfill the centripetal condition, so guys, here na is this, mg is down. Okay, and it is moving with the velocity va. So the net centripetal force, the net force should be equal to what guys, the centripetal force. Okay, so here what I can write, na minus mg is equal to mv square by r. So m v square is what guys, 6gr divided by r. Okay, so r cancel guys, so na will be what, 7 mg. Okay, na will be what guys, 7 mg. Okay, and now if you go if you want to go at guys what, at point B. So at point B, if you want to go, so what we can do guys, we can calculate the velocity at point B. So guys, point B, if we want to find out the velocity, vb square will be equal to what guys, simply we can use the formula va square minus 2g r 1 minus cos theta guys. So here va will act as a what guys, v naught. Okay, so vb square is equal to what, va square into, no, sorry, minus 2gr 1 minus cos theta. So guys, vb square will be equal to what, if you see, that is va is how much guys, 6gr root 6, so it will be 6gr minus 2gr 1 minus cos 180, because we are going at the topmost point. So guys, it will be what, plus 1. Okay, so it will become how much? It will become uh, 4 gr and 6 gr, guys. It will be root 2 gr. Okay, this is the velocity that you will be having at the topmost point. Vb will be what, guys? This. Okay, this is Vb. So if we see, guys, here in this case, so if you see, this will be what, guys? Your Nb, and this side only you will be having what? Your Mg also. Okay, so Nb plus Mg is equal to what, guys? Your Mv square by R. Okay, so guys, here what we can say? We can say that Mg plus Nb is equal to mvb square by R, that is the centripetal condition. So guys, Mg plus Nb, m 2gr divided by R guys cancel, so Nb will become what, guys? Mg. Okay, so guys, the topmost point, the centripetal, sorry, the normal force will be what, guys? Mg. Guys, one note you should keep in mind, that the difference between the tension or normal force of at points bottom and top will be always 6 mg if particle is performing full circle. Guys, you can test this. Okay, you can solve the general situation. If you solve for general situation, you will see, guys, that the difference is always coming what? 6 mg. Means what I am trying to say is T bottom minus T top. Okay, guys. Okay, this is bottom, is always going to be what, guys? 6 mg. Or if you want to write n bottom minus n top, it is going to be what, guys? Always 6 mg. Okay, so you can remember it as a result. If you remember this, guys, automatically, like, we don't need to solve this NB problem. Okay, we could have solved this, the bottom one, and we have taken the difference, and we could have gone the NB directly. Okay, so these kind of a facts sometimes help us to save a lot of time. Okay, so you can remember this, guys. Now coming to the last part of this question, guys, question C. Okay, that is what, guys? If h is equal to what? 2r, then what would be the velocity when the body loses the contact with the track? Okay, guys, so let's see, guys, this also. So here if you see, uh the thing is, guys, in this case, guys, okay, just give me a second. Guys, in this case, if you see, uh this is, let's say, your track. Okay, this is your track. We know that, guys, the particle will go in the upper half, and somewhere here maybe it will do the jump, and it will go like this. Okay, so it will lose the track here only. Okay, suppose. So it is going to get some obtuse angle here. Okay, from the bottommost point, the velocity, guys, first let's calculate at the here. Okay, what would be the velocity at point A? So guys, the VA, if you want to calculate, what you can do, it will be mg into 2r is equal to half m v square. So cancel, guys, so v will be root 4gr. Okay, so at the bottommost point, guys, you have the velocity of how much? Root 4gr. It means the particle can't go up to the topmost point. It will what, guys? Perform the projectile motion. It can't do the full circle. So guys, in this case, if you see, what we want to find out that where it will lose the contact. Okay, so guys, tension is going to be what, 0. Okay, so when the tension will become 0, you can find out here theta, and then guys we can find out v easily. Okay, so guys, if you see here the if you remember the formula that I had told you, we can directly solve the problem, otherwise you just have to derive it once again. Okay guys, so t, we have to put 0, which is equal to what, 3 mg cos theta minus 2 mg plus mv naught square by L. Okay, so guys, here if you see, it will be what, 3 mg cos theta minus 2 mg plus m v naught square will be what guys, 4gr, and L is what guys, r only, so r cancel. So 0 is equal to 3 mg cos theta minus, guys, it will become what, plus 2 mg. So cos theta will be what guys, it will be minus 2 by 3. Okay, so this is of course a obtuse angle. Now guys, if you want to find out velocity, so velocity will be what at this moment is under root of v naught square minus 2gr 1 minus cos theta. We can put the values direct. So guys, it will be what, v is how much guys, 4gr we had seen, so it will be 4gr minus 2gr 1 minus 2 by 3. Guys, if we solve this, what we will get is 4gr so it will become 3 and this 2, so 5 by 3, so 10 gr by 3 guys, this is 12 minus 10, that is what, under root of guys what, 2 gr by 3. That would be the answer of the guys what, last part. Okay, so you can see it's a good problem guys, a lot of concepts all we can say has been covered in this problem. So if you want, you can visit again. Okay, you can see this. Okay, it's a good problem. Now coming to the guys second problem for today, question number 2. So guys, the question is, there is a uh, hemisphere. Okay, there is a hemisphere. It's a very standard problem guys, from Erodo only. Okay, so let's see, let me make a proper shape if I can make it. So guys, I hope it can, no. Okay, let me do like this way. So guys, this is the thing. Okay, and we can remove the lower part. Okay, so let's remove the lower part. What they are doing nowadays. So guys, now if you see, let's say this radius is what, this is r, there is a body guys, it's let's say a point mass. Okay, it is placed on the topmost point, topmost height, and now guys, we have given it a, it is a gentle push. Okay, we have given just it is at a gentle push, means its velocity is almost 0 but not equal to 0 guys, just little bit what more than 0. Okay, so that it can go down. So guys, the question is, at what position, at what position it will leave the contact from the track. Okay, at what position it will leave the contact from the track. So guys, if you see here, the thing is, when it will reach here, okay, suppose the contact is going to be lost. Okay, so if contact is going to be lost guys, it means what, it means that this normal force is going to be what, 0. Okay, the normal force is going to be what guys, 0. So because guys, it is still, you can say, at the verge of what, going to lose the contact, so it means the particle is still following the what, circular path. It means guys, we should we can apply the centripetal condition here. Okay, so guys, if you see, let's say this angle is what, theta. So guys, if this is mg, so this will be also what guys, theta only. So here, if let's say the velocity of the particle is what guys, v, let's say if it has gone down this much, So it has gained some velocity, and this velocity is v. So we can apply the centripetal condition, and guys we will be done and we can get the answer directly. So guys, if you see here, if you see guys how much down it has came down guys, here let's say this height is what, h. So guys, if you see this value, this value will be what guys, because this radius is what, r. So this value will be what guys, it is r cos theta. So guys, h will be simply how much, r minus r cos theta. I hope this is settled. So guys, if you use this thing, what we can say, that how much velocity it has gained coming down this much. So guys, it will be mg r minus r cos theta, that is the positive work done that has been done here, and that is equal to what, change in kinetic energy. So half m v square minus 0, because initial velocity is almost what guys, 0. So guys cancel. So 2g r 1 minus cos theta is your velocity guys right now. Okay, now guys, when the particle is at this position, okay, when the particle is at this position guys, here if you see, so mg is like acting like this guys, normal force we are assuming 0 at this moment because it is just going to lose the contact. So only mg cos theta is going to be what guys, your the force, net force in towards the center, which is going to fulfill your centripetal condition. So guys, what we can write, we can write simply that mg cos theta will be equal to what guys, mv square by r. So from here guys, if you see, what we can say, that mv square by r is equal to 2g 1 minus cos theta, 2mg 1 minus cos theta guys. You can multiply m if you want. Okay, uh 1 minute, just let me put like this way. Yes, it will be how much, it will be 2mg 1 minus cos theta. You can guys see the manipulation. Okay, so I can place it here, mg cos theta is equal to 2mg 1 minus cos theta. So mg guys cancel, it will become what, cos theta is equal to 2 minus 2 cos theta. So 3 cos theta is equal to what is 2. So theta is equal to what guys, cos inverse 2 by 3. Okay, so this will be the what guys, angular position where the body will lose the contact from the spherical surface. Okay, so pretty much easy guys. If you see, Bernoulli theorem we have used and we have solved this problem. Okay, and let me take one last problem, okay, so that you can get the clarity here. So guys, question number 3, maybe I'll take some more problems maybe in the next lecture. Okay, so that you feel confident in this part or in this section. Okay, so guys, one more problem I want to take. Okay, so let me take one more problem guys. This question is my original question. Okay, you can say. So the question is simply like this: draw the force diagram of 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 1 minute guys, force diagram of normal that would be acting on the bead which is given a velocity of root 4 gr at the point A as shown in the figure. So guys, here if you see, this is the problem that I am having for you. So if you see guys, okay guys, so here let's say this is your bead, guys. This is your bead. So right now, guys, if you see, there are two types of normal forces that is possible. Okay, if bead is, guys, what if bead is like this, okay, means it's this end is attached with the ring. So in that case, guys, normal force will be what, in this direction. And if bead is attached like this, guys, if it is moving like this, then the normal force will be what, guys, it will be in the outward direction. Can you figure it out or not, guys? If the bead is attached to like this, means the outer part is, guys, there. So on the this, guys, on the bead, the normal force will be acting what, outward direction. So this you have to keep in mind. So, guys, here in this case, let's say if you have given the velocity of how much, root 4 gr. Okay, guys, root 4 gr is the velocity that you have given to the bead. So, guys, what we know that when the bead will be moving in the lower half of the circle, the tension or the normal force should be, guys, what, will be non-zero, means there will be always a force towards the center we are going to observe. Means, guys, what is going to happen for the lower half of the circle, okay, for the lower half of the circle, even the velocity would be less also, guys. In that case also, it would move like this way only, that, guys, it will go like this, go like this, go like this, go like this. Okay, so, guys, here the right now normal force is what, guys, like this only. So if you see the vector diagram, so it will be more, and then, guys, what, a little less, then a little more less, and then, guys, a little more less, 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 less. Okay, now if you see, guys, we know that at a certain moment, guys, actually the normal force is going to be what, zero, because velocity is not equal to what, root 5 gl, as we have remember. And, guys, I had told you that the tension will convert into what, compression, actually. Okay, so, guys, here what is going to happen, and at this moment the velocity will not be zero, so the particle will go above, because the mg cos theta is what, guys, increasing towards the center. Okay, if you remember. So, guys, what we can do here, if you see, the thing is, the body will go further and it will lose the normal force, guys. Okay, lose the normal force, and let's say here it becomes what, zero. Okay, this angle we can find out, we will discuss this thing now, guys. Here normal force towards the center becomes what, zero, and now the force will convert into what, guys, in the other side. Means now, guys, the ring will start behaving like what, like this. Okay, it will behave like this. Okay, okay, guys, earlier it was what, inside. Now, guys, it is going to what, it is going to move like this. Okay, if you see, guys, here, and the normal force will be what, guys, normal force will be on this, will be what, guys, in this direction. Okay, so if you see, uh, if I make it like this, guys, so normal force will be increasing, 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 guys, and it will be what, maximum here. And, guys, then if you see again, guys, it will start going down and going down, guys, and the velocity is what, zero. So I think I have a little messed up here. Okay, just 1 minute, guys, 1 minute. The ring, I think I have made wrong. Rest is fine, but yes, let me show you once, and then maybe you can understand. So, guys, if this is your ring, let's say, okay, this is your ring. Okay, so, guys, if bead is, let me show the different color of bead, guys. So if this is the bead, okay, this is the bead. So, guys, in this case, what is going to happen, the normal force in the bead would be acting what, guys, what, in the inward direction. Okay, in the inward direction, because this is the touch. Okay, and, guys, if this is your ring, and, guys, if this is the case, this is the case, then in that case guys, the normal force will be acting what, in the outward direction. I hope this is fine. So guys, here uh bead should be what guys, here is outside. Okay, bead should be outside. I hope you're getting my point. Bead should be what guys, outside. Okay, and force would be decreasing. Okay guys, so I hope you're getting my point. Here also guys, it is like this way only, and then guys, here it becomes 0, and then the ring comes down guys. Okay, comes down, 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 down guys, and the force of normal force will be what guys, in the outward direction. And then of course here also guys, it will go like this, and then normal force will be what guys, start decreasing, but still what, outward you can say. Okay, and then now it goes in the outward direction guys, and the tension start what, increasing. Okay, it would be symmetry only guys. Okay, and here, and guys, whatever the like size will be what guys, symmetric, and it will go like this. I hope guys you are able to figure it out, that what would be the picture of what forces here when the ring would be what, moving, sorry, bead would be moving inside the ring. Okay guys, so I tried this kind of a problem, like we can just ask by giving the options A, B and C and D, and just show some sort of what pictures, like the correct picture if I make guys, one option I'm just making again, and then I think we are good to go for today. So guys, what I'm trying to I was trying to show, let's take only this point A, B, C, D, E. Let's say guys, here also you can put F, G, H. Okay, so guys, here what will be happening, the ring would be what guys, it will be in the outward direction. Okay, the ring will be what guys, in the outward direction, and let's say here this is the critical point guys, where the velocity is non-zero, the normal force will become what guys, 0. So after that if you see, so here the normal force will be what guys, like maximum, and then of course less, and then little bit less, and then guys, as you go above than this, it will be something like this inside the ring will be what guys, inside, and the normal force will be what guys, outside. Okay, certain value, and when here you will ring will be what guys, inside, and maximum normal force outward you will see, and guys, here it is pretty much symmetric with this one. So here also guys, ring will be what, inside, and it will be what, sorry, bead would be what guys, inside, and you will see like this, and when it is coming down now, so ring will come what guys, ring will go outside now, and the normal force will be what, inside, and here also guys, ring will be what, outside, and normal force will be what guys, inside. Something like this kind of a force diagram we can show. So guys, if they want to go in a very fundamental way to see that have you understood actually the concept, I think they can create this kind of problem in advance. Okay, so okay guys, I think I have taken 2 3 problems. Okay, which can give you what, a certain clarity in this vertical circular motion. Maybe I'll take few advanced problems in the next lecture, and then I think we are only remained with what, the rotating frame and the fictitious forces like Coriolis force, Euler force, and the centrifugal force, of course the main one that you guys have heard. So we will discuss all those things in that lecture, and then we'll be good to go with the circular motion. Okay guys, thank you so much.